Hello class, I'm going to walk through finding our correlation coefficient, which is the letter R, by hand. I highly recommend though that you try to use Excel and use the formula equals CORREL, but we will walk through this small one by hand. So we're going to start, these are our ordered pairs, 1, 1, 2, 2, 2, 3, and 3, 6. And I've created this table showing x's, the 1, 2, 2, and 3, the y's, 1, 2, 3, and 6. So this is just our ordered pairs, what you see in the shaded gray, and then created columns for everything that we're going to need. So in this formula, you can see we're using x squared, we're using y squared, we're using x times y, and we're also summing up some of these values. We're summing up x squared. That means we're taking all of our x squared values and adding them up. Here, because our parentheses is around the summation of x, is we're looking at the sum of the x's, and then we're squaring it. So all the values that we're going to need have been populated in this table. So x squared is simply x times x. So 1 times 1 is 1. 2 times 2 is 4. Again, and then 3 times 3 is 9. So this column is x squared. Y squared is just taking our y value and multiplying it by itself. So 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 6 times 6 is 36. And then this column is x times y. So we've taken 1 times 1 is 1. 2 times 2 is 4. 2 times 3 is 6. And 3 times 6 is 18. This last row that I've created is just summing up the values in each of these columns. So 3 plus 2 plus 2 plus 1 is 8. Likewise, 6, 3, 2, and 1 is 12. And I've just in each of these columns added up what we see. Okay, so this is the sums. This is what this symbol right here means. It means sum up whatever comes after it. And then the other thing that we're going to need that I've already mentioned is taking a sum of a value and squaring it. So we need the sum of the x's, squaring that, and the sum of the y's and squaring that. So that's what I've done right here. I've taken the sum of the x's, which is this column right here, and this row, which is 8, squared it and get 64. 8 times 8 is 64. The sum of the y's, which is 12, squaring it, which is 12 times 12, and we get 144. So now basically we have all the numbers that we need to plug into this formula. So we're going to start with the numerator, which is the top. And I'm going to use Excel because I'm here, but you could use a calculator, whatever you want. N, as you hopefully you remember, N is always our sample size. So it's how many ordered pairs do we have? So N is 4 because we have 4 sets of ordered pairs. So I'm starting equal because that is telling Excel I just wanted to do the mathematical operation, 4, and I'm going to multiply that times the sum of x times y. Well, here's x times y, and the sum of that column is 29. And from that, I'm going to subtract the sum of the x's times the sum of the y's. The sum of the x's is 8, and the sum of the y's is 12. So 8 times 12, hit enter. So this is going to be, my numerator is going to be 20. So I'm going to do the denominator in 2 parts. We have the square root of this, and then we have the square root of that. So I'm just going to take it in pieces to make it easier. So first I'm going to do what's underneath this square root symbol. So again, we have n, which is 4, and I'm going to multiply that times the sum of x squared. So here's x squared, and the sum is 18. And from that, I'm going to subtract the sum of the x's squared. The sum of the x's, is 8 squared is 64. So that's that part of the equation. Hold on one second. So we did this first part underneath the square root symbol. So now we have to take a square root of the 8. And I can use Excel or you can use a calculator. I'm going to type in square root and I'll just type in my 8 and that gives me 2.82. So in the denominator on this first part we have 2.82 and then in the second part again equal 4 and I'm going to multiply that times the sum of y squared and that is right here, that's a 50. And from that, we're going to subtract the sum of the y's squared. And the sum of the y's is 12, squared is 144. And again, we're going to take the square root of that. I'll take the square root of 56, and that gives me 7.48. So to put that all together, on the top I have 20, and I am dividing that times 2.82 times 7.4833. So we have 2.82, I may as well do out all the decimal places, times 7.4833. And whoops, I think because, hold on one second, I'm not showing all the decimal places. Format cells, and I can, oh, you can't see that anyway, sorry. I need to show my decimal places, and now when you don't show decimal places, then Excel rounds that for you, but I want to see my decimal places. So the correlation coefficient is 0.94492, which is what I did by populating this table and putting it together. Or we can just use the formula in Excel, CORREL. Whoops. And I have to highlight my X's, followed by a comma, highlight my Y's, hit enter, and 0.9449. It's probably because I don't have 5 decimal places showing there. But this is doing it manually. We get the same thing when we use the Excel formula. And then the next step is to see whether or not this is significant at 95% or 99%. And that significance is based on your sample size and the critical values in this table. The 0.05 corresponds to your 95% significance, and the 0.01 corresponds to your 99% significance. This value, this R value, needs to be greater than both of these or one of these to be considered significant. So we have 0.945, which is less than 0.950, and it's less than 0.999. So our relationship, our correlation of these two numerical values is not significant 95 or 99% of the time, even though it looks quite significant. But what's hurting us here is our small sample size, a sample size of just 4 ordered pairs. You can see as the sample size decreases, the critical value increases. So it's a higher standard because you have so little ordered pairs to be considered significant. The more ordered pairs you have, these critical values decrease because you have a lot of data, is basically what it boils down to. So that's walking it through manually. But you do not have to do this ever if you choose to use Excel or some other tool to find the R value, which is your correlation coefficient.